In this problem, we know that W is the midpoint of XY because it's given in the problem. That means that this triangle is actually an isosceles triangle because we can see that this height that's dropped down here is perpendicular to the base, which means, and then we know this is the midpoint, so it must be true that this side is also 20. Now, in this case, we want to find the value of WZ, which is that height right here. In order to do that, we are going to use the fact that this is part of a right triangle, right? I'm going to highlight it for you right here. We need to figure out the sides that we do know so that we can substitute into the Pythagorean theorem. Well, we obviously know that this side is 20, it's given. We know that this entire base for the length of xy is 24, but because we want only half of that, we need to cut it in half. Half of 24 is 12. And then our question mark is our height here that we don't know. First of all, we want to label our C. 20 must be our C because it is the longest side, the hypotenuse, across from the right angle, which means we can use our question mark as our A. In our formula, that would be a squared plus b is going to be 12, so 12 squared equals 20 for our c squared. Now, a squared we do not know, it's going to stay a variable. 12 times 12 is 144, then 20 squared is 400. From here, we need to solve this equation. We need to isolate this a squared by undoing the 144 on both sides, so that means we need to actually subtract. A squared will be left over on the left. On the right, if I do 400 minus 100, that's 300. Now, 44 is close to 50, so if we subtract 50 from 300, that's 250. But 44 is 6 away from that, so I would get 256. All right, and then our last step is to undo the squaring by square rooting both sides. And the square root of 256 is actually equal to 16, which means the height for this particular triangle is equal to 16.